So impulse is force times time. And we can use that to calculate impulse or change in momentum, but that only works if our force is constant. However, we know that if we're multiplying something by a delta something else, that usually also represents an area under the curve, and it does in this case too. So impulse is the area under the force time curve. So if our force is changing over time, if it's not constant, we can still use the graph and find the area under that graph to get the overall change in momentum. And in practice, whenever two objects collide, the force is usually not constant over time. We can see this is real data taken with a couple of force meters. As the ball initially collides with the meter, the force is smaller, and as the ball starts to compress, the force is bigger. As it bounces away, the force reduces. But that total area still gives us the change in momentum. Let's take a look at an example here. Here we have a graph of force in newtons against time in seconds. And we have a 1.5 kilogram mass traveling to the left at 6.0 meters per second, then experiences an impulse represented on this force time graph shown here. Take a minute, pause, and try and solve these three questions. Okay, let's solve them. What is the total impulse given to the ball? Well, we know it's the area under the force time graph, so let's break this down to find the areas. This section is a triangle, and the area of a triangle is 1/2 base times height. So it's 1/2 times 0.1 seconds times 50. That gives me 12.5 as the area. This area is a rectangle. It has a base of 0.3 and it has a height of 50. 0.3 times 50 is, I believe, 15. Whoops. Sorry, I made a mistake here. This isn't 12.5, this first area. It is 2.5. 2.5. That's why I paused there. The second area, 0.3 times 50 is 15. And the third area, same base, same height as the first triangle, so that's also going to be 2.5. So our total area under the curve is, it's going to be 2.5 plus 15 plus 50. Or plus another 2.5, which is 20. So the impulse is 20 newtons seconds. Okay, question 2. What is the change in momentum of the ball? Well, change in momentum is just equal to impulse. Delta P equals J. So it's just 20 kilogram meters per second. And then last of all, what is the final velocity of the ball? Well, we can use what we know about momentum to find the final velocity. Because momentum is mass times velocity, so change in momentum is going to be mass times change in velocity, as long as my mass is constant, which it is for a ball. So I could say delta P, which is 20, is equal to mass, 1.5, times final velocity, which is my unknown, I'll write it as V, minus my initial velocity. And what was my initial velocity? It was 6 meters per second to the left, and it said take right to be positive. So my initial velocity is -6. That direction is very important for a vector. Whoops. So it's going to be V minus -6. And we can solve this out for our unknown velocity. Divide by 1.5. We get 13.3 equals V minus -6, so that's V plus 6. Subtract 6 from both sides, V equals 7.33 meters per second. And that's it. Bye.